Here is the next question. It took me a while to interpret the question first. Anyway, so here is a RLC series circuit. You have RLC and L value is given, which is 0.2 microhenry. R value unknown, C value unknown, but he mentioned the station will be having a frequency 105.7 megahertz. So that's the resonant frequency. Basically the resonant frequency is 105.7 megahertz. So we can find the C value. So f naught equal to 1 over 2 pi square root of LC. By using this you can find C value. C value equal to 11.336 picofarad. So solving first part is easy, nothing. And to reiterate, the resonant frequency is nothing but at resonant frequency the circuit is going to have only resistance, because at lower frequencies on this side here it's lower frequencies XC value is higher because omega value is lower and XL value is lower, so you will have R minus JXC, so magnitude square root of R square plus X square, so you will end up having more impedance there. And when you increase the frequency, omega L value goes up, so that's another reason you will have more impedance there. And we can clearly see when it comes to the DC circuit where frequency is 0, capacitor acts like a open. So if I put 0 here, I mean frequency omega value 0, XC value is infinite, it acts like open circuit. And for higher frequencies, so omega value is very high, inductor is going to act like a open circuit. Okay, but we know the capacitor in DC it acts like open circuit, and higher frequency it acts like a closed circuit. And so the black line is a impedance line, so the blue line is a current line. So wherever there is a low impedance, there we will have more current passing through it. So far we know f naught equal to, which is resonant frequency 105.7 megahertz, and at that frequency the current I naught equal to E naught over Z, and Z is nothing but resistance in this case because XL equal to XC. This is at resonance. Now moving back to the second portion of the question, the second portion he's talking about FM radio stations. When it comes to FM radio station frequencies are in between let me use 88 megahertz to 108 megahertz. And when they assign the frequencies, I mean they don't assign 88, it's going to starts with 88.1 megahertz, and next station is going to be 88.3 megahertz and 88.5 megahertz, something like that. Okay, if you look at our KMUW radio, it's 89.3 megahertz. Okay, like that for each 0.2 megahertz each station is going to be divided. So that's what the first statement says. FM radio stations assign frequencies every 0.2 megahertz, but two nearby stations cannot use adjacent frequencies. So two stations in our city cannot use the 88.1 and 88.3 because mismatch. I mean since the frequencies are close by, so if you put the 88.1 megahertz radio, maybe you may hear something from 88.3 megahertz radio, so they will keep frequency differences if the stations are nearby. Now what is the maximum resistance? So our goal is finding the resistance value, maximum resistance the tuning circuit can have if the peak current at a frequency of 106.1 megahertz. Understanding this, it took me a while, but don't stop it here, you need to continue until this. The closest frequency that can be used by a nearby station is to be no more than 0.2% of the peak current at 105.7 megahertz. So another station, so he's picking up another station which is 106.1 megahertz. That station can have a peak current of only 0.2% of the peak current at resonant frequency. So here, so now at resonant frequency we understand this. Now at 106.1 megahertz, let me take that current as Ix equal to E naught over Z. That current must be only 0.2%. 0.2% is nothing but, when you convert it into actual value, it's 0.002 ampere. Okay, so Ix must be only 0.002 times I naught. I naught is the maximum current. So Ix is nothing but E naught over Z, E naught over square root of R square plus XL minus XC square, and I naught is nothing but E naught over R. So I substituted it here. So now if I mean here E naught and E naught get cancelled out, so I will end up with square root of, I mean, if I move them to the other side, move them here, you will end up with square root of R square plus XL minus XC square equal to 500R. Now R square plus XL minus XC square equal to 500R square. XL minus XC square equal to, so 500 square is nothing but 25,000, not 25,000, 2.5 thousand. So minus 1, 2,49,999 R square. Okay, now I'm going to substitute XL is nothing but omega L, which is 2 pi. F is 106.1 megahertz L, and XC is 2 pi 106.5 times 10 to the power of 6. C value is what we have. C value, we just found that value, 11.336. Okay, C value is 11.336. So we substituted those values. Okay, so after solving this, I end up with resistance value as 2.3 milli ohm. That's the resistance value needed for this RLC series circuit. Okay, it's a little bit confusing if I read only this statement. Okay, but if I combine them, now does it makes sense if I combine from here to here. Okay, thank you. I will solve the next examples in another video.